Hello everyone. So today we are going to do Leetcode Daily Challenge subset. So here I've written that how it could be done. So let me first show you that. Okay. So let's get to the description of this question. So basically in this question we are given with nums vector, right? In which we would be given with some elements that 1, 2, 3, right? And we need to get out all the possible subsets and need to return that as our answer. And the answer format is simply vector of vector int. That is, we don't need to just see out it, but we need to store into a vector of vector int, right? And this is how we would be simply storing the subsets of this particular input vector which is being given to us. And this could be returned in any order. Now, comes the next part at how we would be required to do this particular question. Okay, so now the thing is that subset, what a subset is, right? So there are 2 raised to power n subsets are there, and the power set has 2 raised to power n sets. Basically, what I want to describe here is basically a set is given to us, and how many subsets we can form, right? So that would be simply that all the subsets combining together would simply form a power set. So that is what I have written here. And how we can form all the subsets, we can simply use recursion and backtracking method, or we can simply use this bit manipulation method. So we could, I'm here, in the coding part, I would be explaining with the bit manipulation part, but here I would explain the recursion backtracking part also. Now comes the part of recursion and backtracking. So basically, when we are given with this 1, 2, 3, then how many subsets could be possible? Like first would be the empty set itself, and the last one, this could be the subset which will be having all the elements which are there in our input array, right? So this is how these two subsets would be there. Now comes the part all the single elements 1, 2, 3, and then all the double element combination. These are somehow 3 and this 3, 6, 7, 8. Total 8 subset would be there. That is 2 raised to power n, and 2 raised to power n, as there are 3 elements, so n is 3, so 2 raised to power 3, that is 8, right? So in total there are now 8 subsets, and in total our power set is containing 2 raised to power n, that is 2 raised to power 3, that is 8 sets in it. So this is a thing which we are required to give our answer as. Now, as it is a recursive question, right? So how recursion will work here? Now comes the part options, that we need to choose or not to choose an element. That is the option part here. Then the depth of the recursion tree, that is number of elements in array plus 1. This is what would be the depth of recursion tree, that is this one. That what would be the depth of this recursion tree, and starting with the width of the recursion, that would be simply 2 and 2 into 2 and so on. That is, as we are given with 2 choices for building up this recursive solution, that is either we will be including this particular element or we are not including this element, right? So at the first level of our recursion tree, what we are going to do is we will be having 2 choices. That is, our width at this particular moment will 2 raised to power 0. That is, we are having just 2 choices. Then for these 2 choices, we would be having further more 2 choices, right? Then at that moment, our width of the recursion tree at this moment will be 2 raised to power 1. That is 2 choices here and 2 choices here. Wait a minute, like I have missed something. So basically, here at this moment, it would be 2 raised to power 1. At this moment, it would be simply 2 raised to power 2. That is 4 choices. And like this, it will be going till the end, right? At the first level, there would be only 2 raised to power 0. That is 1 choice, right? Means at this single point, when it is just starting. And then after that, it will go ahead with 2 raised to power, means 1 choice for taking it and 1 choice for not taking. That is the thing which would be here. So this is how a recursion tree would be built here. Now comes the next part. That for now, here is for explanation of the time complexity of this particular thing, right? So first it goes to the depth of inserting all the elements, and when it returns, means when I is greater than equal to n, at first I is equal to first I less than n, right? At that stage, thus it directly goes to return statement only because of that loop condition only. So it pops out the last element at that recursive call state and returns to parent, and the loop starts again from that index of that state. Basically, because of the recursion and backtracking method only, it comes to at a particular loop when a particular condition gets false. Because of that only, false in the sense when in that particular loop it reaches a condition that is I less than n, right? And then I becomes greater than n. Then at particular moment it exits the loop, and whatsoever statements are there in backtracking step, then it goes to there, and because of them it simply, because of that only, it simply do some steps. That's what I've written here. And at that moment only, here the thing is that when it returns, it pops the last element at that recursive call state and returns to parent, and the loop starts again from that index of that state. That is the thing it would be doing when there is recursive and backtracking solution. But at this point, whatsoever index is there, element corresponding to that is pushed into the current. I would be taking some current temporary array, and in that element will be simply pushed. When it again exits the loop, then it returns to the parent and unfinished tasks are again done. Basically, this whole process which I am talking about is that recursive and backtracking solution in which I am simply pushing the present element into my particular temporary array, and whenever I backtrack it, then I simply pop out that particular element only, so that at the next call I could simply push some other element into it, and when some other element is being pushed into it, then I could have another set of solution for me. And when it reaches a particular base condition, then that particular temporary array would be simply pushed into my main answer. So this is what I was explaining in these whole 3 points. Now until it reaches to the main parent function, that is at the top of, right, where now there are no unfinished tasks, then it returns the final answer. Because of that only it then returns the final answer. Alright. Now comes the part, the time complexity and the space complexity for this particular solution. So basically I can say that the time complexity is simply 2 raised to power n into n. Why this would be there? Because 2 raised to power n, because of the fact that we are generating 2 raised to power n subsets, right? Our power set contains 2 raised to power n elements only. Means those 2 raised to power n sets, right? So that's why time complexity is for generating the 2 raised to power n subsets would be 2 raised to power n only into n. N for traversing that particular input array, right? Because just for generating those 2 raised to power n subset, we would be simply traversing our input array n times. So thus it is 2 raised to power n to n. Now the next part is about the space complexity. The space complexity here is simply order of n only. Why order of n? Because of the fact of simply at if we talk about this particular recursive stack, right, then at max at a particular instant it could have only n elements, right? Means that input array itself, because this particular we can see here the maximum length a particular subset could take is the input array's length itself, right? So that's why the stack would have at max n elements only. So that's why space complexity is order of n, and this is for that particular recursive stack. So this was the recursive and backtracking solution method explanation. Now comes the part about the bit manipulation. So here I have written about the bit manipulation also, that how we can do with that bit manipulation. Here comes the part, means here we don't have any recursive stack, so that's why our space complexity is order of 1 here, right? Because we are not using any extra space. But time complexity is same as that of generating 2 raised to power n subsets with the input array of n elements, right? So this is the fact the time complexity is something like this. Now once the part for this bit manipulation thing. Okay, so input array is this, whose size is 3, and power set would be of 2 raised to power 3 elements only, right? So let me explain you with the bit manipulation part. So the thing is, see, we are having this 1, 2, 3, and we could simply count them as bits only. That when this bit is on, that is this third bit is on, right? Then this particular element would be included. Like here 3 is included, then when this here 3 again included, when on, then 3 again included, when on, 3 again included, right? So like this only, whenever a particular bit is included, then its bit would be simply on at that moment only, right? So that's how we would be doing this particular bit manipulation solution. Thus, keeping this concept in mind, that is, given array could be acted as a string of bits. This is the fact, and this is the main idea for implementing this bit manipulation function. Solution, sorry, not function. And we have choice either to add or not to add a particular bit as per the set bit concept. So this is the thing which we are using in our bit manipulation solution. So now comes about the key points which we are required to include in this. That is, we are having counter and one simply shifted by I when it is not equals to 0. This simply for keeping check if ith bit is set or not. If set, then we will push that to our answer. This is just for the keeping a check over the ith bit only. Now, this particular thing, this one shifting by I refers to multiplication by 2 raised to power I. And if it was simply in other direction, then it was simply division by I. So now that is power 2 raised to power I. That is the thing which I am referring to this particular portion. And our counter variable helps in building all the 2 raised to power n subsets. So this is the fact here. Now comes the next part. Let's see about the coding part, that how we are required to do code. Now for the coding part, what we are required to do is, we are first taking this particular steps, the initialization step, initialize and declaration steps, that we have taken the size of our array, our input array, basically our input vector. Then we are having this vector end answer, whose size is again 1 left shifted in, that is I can say it's simply 2 raised to power n only. That is, it could simply store all the 2 raised to power n subsets in it. So that's the size of our answer vector of vector end. Now comes that int power size is equal to power 2 raised to power n. Basically, this power of 2 raised to power n and this 1 left shifted by n, both are same statements only. Just I have written here so that just to explain, I've just written here. That's the thing. Now comes the next part. Now here, this first loop. Basically, this first loops help us to explore all our 2 raised to power n subsets. And this particular loop, right, that is for I is equal to 0 to I less than n, I plus plus. Basically, because of this loop, what we are doing is, we are given with an input array and we are simply checking all the elements which are there in our particular input array. So this is what we are checking here. Now, if this particular happens, that is, if ith bit is set, that is counter, that is there, and 1 left shifted by I, that is 2 raised to power I, then we do AND with both of them, and it is not equals to 0. That is, our ith bit is set, right? Then at that moment, what we would be doing is, we'll simply do answer, then the counter, that is that particular index of our answer, and we'll simply push that particular nums of I, basically that element, into our answer vector or vector end. So this is the thing which we would be doing here. Basically, let me explain you, like here counter. The step which is here is, say our counter is 0 here, right? Then 1 raised this I is equal to 0 and 0. 0 and 0, it is equal to 0, so this won't work here, right? Then comes the part, again counter is 0 only, and then and now I would be 1, right? And it will be 1 raised to I, basically 2 raised to power 1. Again 0 means, let us take some case where it will have some value. So whenever its condition becomes true, like say when it's become 1 and 1, it is not equals to 0, right? It will be simply equals to 1, and it simply shows that that bit is set, right? So at this particular moment, in our answer vector, basically our answer vector is simply like this, means vector of vector in. It is basically something like this, right? So at a particular index which correspond to this counter, say it correspond to this only, this is 0 and this is 1, right? It will simply push back that particular 1, because we are having some like this, means 1 is empty, then it has some element, yeah, it is empty, right? Basically the thing is, here it would be empty, then 1 would be enter, then 2 would be enter, then 3 would be enter, because of whenever that particular bit is set, right? And then we when we are having 1 already here, because it will simply go with all elements only, it will only push it when our bit is set with that particular counter moment only, right? Then it will push this 1 here, and then it will push 3, then 3 is being there with it, like this only it will be keep pushing, and this is what it is meant by these two lines here. So this was all for this particular question, and I've already explained the time complexity part also. Yes, and yeah, time complexity and space complexity I've already explained, and I'm not taking any particular extra vector also, extra space also, right? So that's why space complexity is order 1 only, and the time complexity 2 is to power n into n. So this was all for this particular question. If you have any doubt, you can simply comment down. I'll surely check it. And please do subscribe to my channel and like if you really like the explanation. And this was all for it. So thank you.